Hey everyone, let's jump right in. We are breaking down a massive release in the AI dev space that literally has the whole community buzzing right now. We're talking about the newly released OpenAI Agents SDK. Look, if you've spent any time trying to build autonomous AI systems lately, you already know the landscape has been evolving fast, but man, it's also been incredibly complicated, right? Well, OpenAI just dropped an open-source, lightweight framework that takes years of industry learnings and distills them into something beautifully simple. So, आइए इस नई तकनीक को विस्तार से समझते हैं and decode the anatomy of an agent together.
Okay, I want you to really think about this for a second. What if an AI framework that previously took 6 long months of trial, error, and just pure frustration to master now takes just one single day to understand? No way, right? But according to the dev teams who got their hands on this right after launch, that is exactly what has happened. We're talking about a monumental leap forward for developers. The barrier to entry for building complex multi-agent AR systems, it's just been completely shattered. Okay, let's dive into this comparison, because before this release, building agents with older frameworks like LangGraph or CrewAI often felt like hitting a brick wall. And sure, those frameworks are powerful, but developers consistently reported major frustration. You know the drill. You had to learn complex abstractions, manage states manually, and build intricate routing nodes just to get basic agents to talk to each other. With the new Python-first minimalist design of the OpenAI Agent SDK, all that bloat and legacy code is just deleted. We are left with only the absolutely essential primitives. So here's our quick roadmap for today's explainer. We're going to cover core concepts, agent handoffs, guardrails and tracing, the built-in agent loop, and finally, AI design patterns. All right, starting off with Section 1, core concepts and simplifying the agent architecture. Basically, OpenAI distilled years of learnings down to just 3 main primitives. To really understand an agent, think of it like a human being. It has a brain, which is your LLM, but a brain alone can't actually interact with the physical world, right? It needs tools. Just like you'd use a laptop to write an email or a car to drive somewhere, the agent uses tools like web search, file retrieval, or code execution to actually take action. So you give the agent a persona, give it its tools and a goal, and it uses that LLM brain to figure out exactly how to get the job done autonomously. Moving to Section 2, the power of handoffs, or seamless delegation. This solves a really huge problem of overloading a single agent. See, you can't just pack a single agent with 1,000 tools and expect it to perform well. The performance is inevitably going to degrade. And that's exactly why we need handoffs. A handoff is the seamless transfer of a task from one specialized agent to another. If an agent gets a prompt that's outside of its specific persona or capability, rather than failing or hallucinating some nonsense, it just packages up the entire context of the conversation and hands it straight over to an agent that actually specializes in that exact task. And this brilliantly illustrates the concept. Think of a family delegating tasks to make biryani for guests. You might run to the store to grab the meat, the rice, the yogurt. That's your specialized task. But you don't actually cook it. You hand off those ingredients to your mother or your partner, who is the expert chef, to actually make the biryani. Or, think of a relay race, where a runner sprints their portion and then passes the baton to the next specialized runner. In our architecture, that baton is the context, and passing it is the agent handoff. Let's jump into Section 3, guardrails and tracing. These are the crucial components that keep our AI agents safe and predictable. Because look, once you have autonomous agents running around talking to each other and using tools, you absolutely need safety. That's where guardrails come in. These are strict boundary rules you apply to your agents. You can set them on the input data coming in or the output results going out. If you ask a system to generate a specific output, you definitely don't want it wildly hallucinating something else. These guardrails ensure our autonomous system doesn't go off the rails and stays strictly on the tracks you built for it. To visualize this, just think of guardrails like a security guard at the gate of a residential society. The guard checks who is coming in and who is going out, making sure no unauthorized behavior happens. So, if you build a customer support agent, the guardrail ensures that if a user tries to trick the agent into, say, writing Python code or doing a web search for totally unrelated topics, the agent is strictly blocked from executing that unauthorized task. But alongside guardrails, we also need visibility, which brings us to tracing. Now, in older frameworks, figuring out why an agent failed was an absolute nightmare. But here, tracing is a built-in observability feature. By literally just flipping a switch in the code, every single event, every tool call, and every agent-to-agent handoff is logged. It lets developers easily look under the hood and monitor exactly what decisions the agents are making at any given millisecond. All right, Section 4, the built-in agent loop. This completely shifts our focus from the what to the how, bringing true autonomy. And this loop is a total game changer because it completely removes the massive developer burden of manual prompt engineering and workflow routing. When you run an agent with this SDK, it automatically enters a built-in sequence. Step 1, it receives your input. Step 2, the agent's LLM brain decides if it needs to call a tool, hand off the task, or maybe just answer directly. Step 3, it executes that action, and Step 4, it evaluates the result. Now, if the result doesn't solve the user's prompt, the agent autonomously repeats the loop, trying a different tool or another handoff until the goal is fully achieved. You no longer have to manually wire these steps together. The agent handles its own persistence. Let's wrap up the technicals with Section 5, AI design patterns. This is where we map these simple primitives to powerful enterprise architectures. So, the crucial point here is that the SDK natively supports highly scalable workflows right out of the box. Recent industry research, especially from Anthropic, identified 5 major design patterns for effective AI systems, and this lightweight framework handles all of them easily. We're talking prompt chaining for breaking down large tasks, routing, parallelization, orchestrator workers, and evaluator optimizer loops. You can build all of these complex structures using just those basic primitives. Let's look closely at one example, routing. In this pattern, you have a main manager agent whose only job is to talk to the user. When a task comes in, the manager doesn't solve it. It routes it to the most specialized worker agent. Think of it like a school timetable. If you have an English question, you don't ask the math teacher, right? The manager routes the math query to the math agent and the English query to the English agent. It's incredibly efficient and completely prevents model confusion. As we wrap up this breakdown, I really want to share this poignant philosophical takeaway from the community developers analyzing this SDK. They pointed out that whether you have an engineering degree or you are literally just starting out, your background doesn't matter. What matters is ishq, that deep passion for learning. When you have that passion, you will happily push through 600 code errors, utilizing tracing and debugging until your autonomous agent works perfectly. Your ultimate tool isn't just the SDK, it's your own motivation. And that is the true beauty of OpenAI's new Agents SDK. The complex abstractions, deleted. The framework is ready. That 6-month barrier to entry is completely gone, replaced by a minimalist, intuitive architecture you can grasp in an afternoon. So the only question left for the tech community is this. With the power of autonomous agents now so easily at your fingertips, what will you build today? Thanks for tuning into this explainer, and I absolutely cannot wait to see what you create.